For those of you I haven't met already, my name is Stephanie Shooting. I'm the education coordinator here at 100 Miles, and we are thrilled to have you in our office. This is our first public program in this new space and our first in our office Naturalist 101 since 2020. So we've been doing virtually on and off over the pandemic, but we're so excited to have you all. I also want to thank all of our members that are here tonight, because with your donations, we were able to do these fabulous education programs. So we're very excited to see all of your faces. Again, there's food and drinks in the back, so please help yourself. Also, we're really excited that Writing Books is here tonight, selling, Tracking the Golden Isle. So, and Dr. Martin will also be able to sign those too after the program. So I'm going to stop talking and introduce Dr. Tony Martin. He is currently a professor at Emory. He has written multiple books from the ones we're going to talk about geology tonight, but also about dinosaurs, which I'm excited to look some of those up. But you're not here to hear me speak tonight, but we're really excited that he traveled down from Atlanta to talk to us this evening. So I will turn it over to you.
Okay, thank you so much, Stephanie. Thanks everybody for being here. This is a really special occasion for me because there's my book. It came out in May 2020. Was anything going on then? So to actually be in the same physical space with my book here and with a crowd of people here, to hear about this and other parts of all of the lovely natural history that I've gotten to learn on the Georgia coast, it's really special. So thank you all for being here. We'll start out with thinking about what you're going to learn while you're here. So first of all, you should know that the Georgia Barrier Islands are mostly made of things mixed in there. We're going to learn a little bit about the minerals that you have in there. And the minerals mostly come from the Appalachian Mountains. You probably knew that. And they travel down the rivers. But then we're really looking at what are the eroded bits and pieces of the Appalachian Mountains here. Waves, tides, plants, animals, all of life and all of the forces around the coast also impact and change the distribution of these sediments and the environments that they're in, controlling the ecosystems. And now my favorite part are the traces. The tracks, trails, burrows, nests, feces, whatever life is leaving on the Georgia coast, there are stories connected to those. So what I'll do is I'll talk about the geology first and then connect that geology to learning about traces. And the study of traces is called ichnology. Not ichthyology, ichnology. Okay, so this is field research, right, in geology. So this is Montana, and over on the left, I'm looking at some fossil insect pupae and some fossil insect burrows that are in the rocks there. These are in rocks from 75 million years ago, very close to where there are some dinosaur nesting grounds in this northwestern part of Montana. Wherever the dinosaurs nested, the insects nested, and vice versa. So this is one of the ways you can use traces to understand something about the environments in the ancient past and the needs of these animals in their ecosystems. And walking over some of that area in the Two Medicine Formation, you see lots of interesting fossils there, trace fossils and body fossils of the animals that lived there 75 million years ago. Now this is in Victoria, Australia, also Cretaceous rocks. These are from about 105 million years ago at a place called Knowledge Creek, which is not easy to get to. So when we were there, we were looking for tracks from dinosaurs. We were also looking at some of the insect burrows that were in the rocks there. Some burrows that I think were probably from turtles. What was fascinating about this place was that these rocks were formed by rivers near the South Pole when Australia was still connected to Antarctica. So we're talking about polar dinosaurs and polar animals living in those ecosystems then, 105 million years ago. So yeah, there's more geology research too. How about that? Yeah, that's geology research too. It is, that's field research. And this is Ruth and my favorite activities that we like to do around Thanksgiving is take our bikes down to Jekyll and ride on and around the island. And while we're riding on the island, we often see some very interesting traces or other evidence of what life has been doing. So this can be field research too. And in fact, the last time we were there in November, As we were riding down the beach, we saw something new there. So those of you who have been to Jekyll, or if you're coming from Jekyll, you might have seen this. About halfway down the beach toward the middle of the island, you'll see these kind of muddy deposits that are coming out. Those are marsh deposits. Those used to be marsh environments. Before that beach was eroded there, that marsh was there maybe 500 to 1,000 years ago, buried by the sand, and now erosion is bringing that out so that we can see that. So even riding our bikes along the beach, we get to learn some geology.
What's the texture of those?
Oh, the texture is muddy, but it's really firm mud. So it's funny because, yeah, if you ever walk out into a salt marsh here, which I don't recommend, unless you have a friend to pull you out, yeah, you might go into the marsh about like that. This, you can stand on it. So what's happened is the mud has been compacted and it kind of squeezed the water out of it, and now it's more like modeling clay. Yeah, you're welcome. And then I always love seeing these dunes whenever you see a cross section of a dune. And this is just like what you would see in the geologic record. If I saw this kind of cross bedding, I would go dune. And then I would understand something about the environments of that place, going back to the Jurassic, Permian period, or whenever. So with Georgia, we are really blessed with good geology in Georgia. Unfortunately, a lot of it is covered by kudzu, but still, we have really good geology, really complicated geology. If you go to the northwesternmost corner, up near Cloudland Canyon State Park, for instance, that's more the Cumberland Plateau. If you go a little bit southeast of there, that's the Valley and Ridge. That's actually where I did my dissertation fieldwork, was looking at Ordovician age rocks from about 440 million years ago there. The Blue Ridge up to the northeast then is going to have some metamorphic and igneous rocks. And then the Piedmont, metamorphic and igneous. Ruth and I, we went over to St. Simons and we saw the huge boulders there on the shore. Those are from the Piedmont, not local. And then in the coastal plain, which takes up more than half of the state of Georgia, the coastal plain are more or less flat-lying sedimentary rocks that were formed in the last 70 million years or so. Then, of course, the barrier islands, the jewels of the geological crown here along the coast. But you could simplify that where you look at these different provinces, and then you think about with the coastal plain here, that this is the fall line that's connecting, or that Piedmont then, where the sea came up and the sea actually eroded up to this part. So Columbus and Macon and then Milledgeville are all along that fall line. That's the more hard crystalline rocks that didn't weather down as much. There probably were dinosaurs up in these mountains then. And you actually have dinosaurs from the Cretaceous period that were separated from the dinosaurs out west. So we kind of call them Appalachian dinosaurs. So they would have been in this area, but the rocks are not preserved. Occasionally we get bits and pieces of those dinosaurs or other land-dwelling animals that go onto the coastal plain. But some of the rocks that are then from later have some of the oldest whales in North America that are also preserved down there in the coastal plain. And some of the oldest sand dollars in the geologic record also come from just south of the fall line. So let's see, yeah, now we're going to think about, as these rocks are eroded, as they're eroded, all of the minerals go downhill. Now this is because of a little known and little understood theory called gravity. You've heard of it? It's just a theory, okay? It's just a theory. But still, under this theory then, what's happening is the water is going down gradient, taking the sediment with it, and in each of these drainage basins then is taking it down to the coast. So the Satilla, here's the St. Mary's, the Altamaha, the Ogeechee, Savannah rivers basins are all taking those eroded bits and pieces from the Appalachians originally, but also the coastal plain down the coast where the waves and the tides and all of the life is going to be moving them around and changing them. So sand, this is something I always teach my students. Sand is a size term. It is a size term. It's referring to any particles that are between 1/16 to 2 millimeters diameter. So then we have different compositions for the sand. Once every 2 years, I take students down to the Drace Research Center, San Salvador Island, the Bahamas. I actually have one of the alums from that right here, Ben, thank you. Yep. He survived, but I take them down there for an intensive field course that we do there. All of the sand there is made of calcium carbonate, aragonite and calcite sand. Here on the Georgia coast, most of it is quartz. You do have some other minerals in there too, some feldspars, like potassium feldspars or plagioclase feldspars. You might even get micas in there, but you also have these so-called heavy minerals. These are going to be more like iron, titanium, or iron oxide kind of minerals. So they're going to be more dense than the quartz and some of the others. Now we also have lots of shelly material that gets broken up in bits and pieces, so we get some of those in there too. Again, calcite and aragonite, calcium carbonate, that gets mixed in with that too, but mostly quartz. What's cool about the heavies is that you can see them on a beach that's had a little bit of scouring, maybe by the tide and waves. So they're going to get left behind. And then if you get a good wind going across there, then it's going to leave these behind in these really nicely defined streaks. You'll also see them in some of the crossbed parts of the dunes. So if you're ever going down to Georgia Beach and you start seeing some of this black material here, it's from those kind of minerals that are showing up and they're getting concentrated there. And yet they also sometimes make really cool traces. So if you get a dog or some other animal that's walked across this, makes for some really nice artistic looks to those traces. So again, when you look at these crossbeds, look at the dark layers. Now you'll know that those are from iron and iron titanium, heavy minerals that are being left with some of the lighter minerals mixed in, but you're also seeing with the bedding how the wind changed direction and is carving in new places where that sand gets deposited. Sometimes in this too, you can see some of the burrows that cut through there where you might have had insects, ghost crabs, or some of the other animals that burrow in here. Once in a lucky instance, I will sometimes see the cross section of a deer track too, where you'll see deer had stepped in and deformed some of those layers. So silt and clay are also size terms. When you talk about silt, that's between 1/256th of a millimeter to 1/16th. I didn't make the rules. That's what they are. Clay then is the size of sediments that are less than 1/256th of a millimeter. Coincidentally then, a lot of clay minerals in their composition, like good old Georgia kaolinite, for instance, illites, smectites, all of those kind of platy minerals are also oftentimes broken down to those sizes. And these are often the weathering products of feldspars and other minerals that they end up going down to the Georgia coast. Now, very simply then, silt plus clay, mix it up, that's mud. As far as a person like me who studies sediments, that's what I would call them, that's mud. Here's the cool thing about that mud. All that marsh mud, it's all poop, almost all of it. Bivalve poop. So what's happening is the mussels in particular, the mussels that are out in the marshes, they suck in the water with suspended organic goodies. There's clay in that water. That's why the water you'll see is kind of brown because of the suspended clays. They suck that in and then they eject it as the feces, and there's a little bit of mucus holding that together, kind of shrink-wrapped fecal mud there. And it gets deposited as the hydrodynamic equivalent of sand. That's how the mud gets deposited. Otherwise, it would be suspended forever. So this was something that Jennifer Smith, who worked with my original advisor, Bob Fry at University of Georgia, that she did her dissertation on this and determined that that's how most of the mud was deposited. Because otherwise, with these tides around here, you would think the mud would just stay in suspension forever. So it was a really big aha light bulb moment of how does that mud get deposited? And it's like, and then you get these, chocolate sprinkles. Oh, how many of you have tasted these chocolate sprinkles? You have? Yeah, they weren't very good, were they? Okay, so you'll see these too. This is also how mud gets deposited then on the beaches. When you see what looks like these chocolate sprinkles getting accumulated there, those are from animals that are living well below the beach. So this is from ghost shrimp. And probably a lot of you already knew that. You've seen these little volcanoes all along the beach, and they have the sprinkles outside of them. Look at them. They look so delicious. But there they are, and then they get washed by the waves and tides and then accumulate into the troughs of some of the ripples on the beach. That gets preserved sometimes in the geologic record. So whenever I see something that looks like that in the geologic record, I just assume it was something like this. Well, geologists actually started figuring this out by understanding modern ghost shrimp on the Georgia coast and seeing where those ghost shrimp were. Where were their burrows? And they saw the burrows were on the beach at low tide, and they also go a little bit offshore. So they used this as kind of a prospecting tool, because once they started identifying some of the fossil burrows from these ghost shrimp, they were able to see where the barrier islands used to be. So on the lower coastal plain, we have all of these sand hills that are going in this nice kind of northeast southwest line. These are ancient shorelines. So going back to the Pleistocene epoch, about 2 to 3 million years ago, when sea level was here, went down, went back up, went down, went back up, and then you get these ridges that are showing where the sea level used to be. The ghost shrimp burrows, the geologists used them where they found them in the sand ridges, said beach was here, beach was here, beach was here. And they were able to map this in the mid-1960s. It was quite a revelation to know that this was a way to understand where the barrier islands used to be back in the geologic past. Now, what I did here with this is to show you also that the 6 barrier islands that we have, let's see, St. Catherine's, Sapelo, Little St. Simon, or actually St. Simon's, Jekyll, Cumberland, and then go up to Ossabaw. Those islands also have the Pleistocene shoreline sediments and the modern Holocene age. So Pleistocene goes back about 2.5 million to about 11,000 years ago, around in there. The last time sea level was that high during the Pleistocene was about 40 to 50,000 years ago. So where you see the red, that's the shoreline, and see how with Ossabaw it splits right there off from where the modern shoreline is today. So these are some of the few barrier islands in the world that have this. I'm teaching a class right now at Emory once every 2 years called Barrier Islands, and that's something I always brag about with the Georgia Barrier Islands, is that they have so much science that's been done on these islands, but also how they're unusual barrier islands for having this combination of Pleistocene and modern shorelines. So this is St. Catherine's Island here. The western part of the island is mostly Pleistocene. There's a little bit that crops out toward the north, which I've studied there. And then you have mostly this relatively new, just in the past 4,000 or 5,000 years, this part of the island is added. Ossabaw is really cool because you see that split. There's the Pleistocene shoreline, there's the Holocene shoreline, and if you go up there, there's Wausau Island. But if you go over there, that's Skidaway. So that's where Skidaway used to be a barrier island that had the ocean lapping on. Now it's more of a lagoonal island that is behind that salt marsh. So whenever you're out on the beach and you see these little volcanoes, know that there are ghost shrimp down there. And the ghost shrimp can burrow 2 to 3 meters down. So think about like 7 to 10 feet. Yes, they go that far down. And we've seen fossil examples that also go that deep. So they have, it's kind of interesting. There's a ghost shrimp if you've never seen one. How many of you have seen a ghost shrimp? Yeah.
Spell it for it. What's go or ghost?
Ghost. Yeah, G-H-O-S-T. Yeah, because they're kind of pale. So there's that. They're also always hidden. There are kind of whispered legends that they exist, and you almost never see them. I've seen maybe, all the time I've been on the Georgia coast, I've maybe seen 5 or 6. Yeah, that get washed out of the burrows. So this is what their burrows look like underneath. So they have this really knobby exterior. They paste it, they roll the sediment, mostly sand, a little bit of mud. They roll it up into a little ball. They seal it with shrimp spit, all natural. And then it reinforces the burrow. It's like bricks in a house. Notice it looks kind of like a wine bottle up there toward the top. So that's a little chimney where the shrimp goes in here and irrigates its burrow, and that pops out the chocolate sprinkles right there. So then you'll have tunnels, you have these burrow junctions, you have these tunnel junctions. Yeah, that's a turnaround chamber right here. These are really complex burrow systems. They're all interconnected. So it's like there's this massive ghost shrimp city down there. Yeah, it's really cool. But this is also a really good prospecting tool for geologists because these preserve well. And then whenever we find them, we know where we are, ecologically, geologically speaking. So here's my side-by-side comparison. There's a modern one eroding out on the eastern part of the shore on Sapelo Island. And then there's a trace fossil one on the western side of the island where you had the shoreline back then, about 40 to 50,000 years ago. Yeah.
Did it not just collapse under the tides? I mean, or is it just that structurally sound?
Yeah, let me go back. That's a great question because there are parts of it that will not preserve. I very rarely have seen fossil examples that show any of that chimney.
Okay.
So that's about 20 centimeters down, about that far down. So that's kind of the zone of active reworking by the winds and tides and waves. But this part, if it's below, it's already buried. So that's more likely to get preserved. And the other cool thing is that sometimes the shrimp, because they're using mud in here, the mud sometimes has iron, a little bit of iron in it. And sometimes I've seen these where they cement like with like iron oxide, and it's like a pipe. I have one in my office that if you pick it up, it's like, well, that's a weird pipe. Where'd you get, which hardware store you get that from? I was like, no, made by Go Shrimps. Yeah.
So do they live all their life under the sand?
As far as I know, yeah. Yeah, we haven't sent little astronauts down there or aquanauts. Check it out. It would be cool to have like a shrimp cam and put it down there and see what's going on. Are they having huge shrimp parties down there? I don't know. But yeah, they do fossilize. And that's the cool thing about these then as prospecting tools where we can then understand what environments were there, what animals were living in those environments, and so on. So speaking of environments then, let's think about some of the Georgia coast ecosystems that we have and how animals and plants interact with those environments. So here on Sapelo, this is a high marsh. And you get kind of these barren areas where you don't see any of the plants there because there's just too much salt that even the salicornia doesn't like it. But notice also that it's been really burrowed by the fiddler crabs. So you had mud fiddler crabs that are churning this over, kind of like earthworms, only in the salt marsh. If you did a cross-section through one of the marshes, you would actually see a variation in the burrows of the animals that are adapted to those different parts of the marsh. So if we go to the channel bank here of a tidal channel, and then we go up here onto the levee, for instance, and then the back levee area, as you change from this darker part, which is more of the mud, as you get closer to the maritime forest, more sandy, maybe some mud, but mostly sandy, then you're going to have this change in whatever animals are living in the sediment, going from the marsh up to the maritime forest. And this is where you would start getting, say, insect burrows, for instance. But you go out here, you're going to get more of the crab burrows, some of the fiddler crabs and some of the other crabs that are adapted to those environments. Same thing if you went from maritime forest through the beach. Cross-sectional view, there's a gopher tortoise burrow. Where are you, Oscar? Yeah, there you go. Gopher tortoise burrow represented. Okay, and then all of these other burrow systems here showing mostly insects, but terrestrial animals that then as you get to the dunes, now you're seeing more of animals that are influenced by the ocean. This is a sea turtle nest right here, ghost crab burrow. And then as you get offshore, then now you're getting into where it's more the full marine animals like the sea cucumbers, some of the polychaete worms, and the other animals that live more in the marine environments. And then this grand one, I love this diagram. It took me a while to draw it. I love it because it's kind of like Where's Waldo, but there's no Waldo. It's just traces. There's not a single animal in there. It's just to show you the great variety of traces that you can get on a Georgia barrier island, from terrestrial to freshwater, marginal marine to full marine. And it's really a great example of just the incredible biodiversity you get because of the sands and the muds that are on these islands, but also the meeting of the sea with the land on these islands and in relatively small spaces. So whenever you look at some of these marshes, think of them as being mud, a lot of clam and oyster poop, but also fiddler crabs aerating it too. And then also be thinking about how when you look at it from the air, like with this drone shot on Sapelo, just thinking about the drainage patterns and then all of the relationships that the animals and plants have with these different types of sediments that originally came down from the Appalachians. Now, this is their home, and that's where they're building it. So with this then, whenever you're at one of the marshes, be looking at, say, wherever you have these clusters of oysters, also some of the mud snails in there, or here where you have the fiddler crabs that are burrowing up those environments, that these are really dynamic environments. They are not sedentary, and in that sense, there's always something going on in these environments with the life interacting with them. Now, some of the cooler things, I mentioned at the beginning on Jekyll, we went bike riding. We see this Relic Marsh. This one has been cropping out on Sapelo Island toward the north end of Cabretta Beach for decades. Geologists studied it back in the 1970s and 80s, and there are different exposures of it every time I go there with students. When I've taken students there, we go up and we look at all of the evidence in here. There's some of the original Spartina. They can still see some of that in there. And then you can see the roots. There are also burrows from the fiddler crabs. Occasionally you'll find some of the mussels, like right there. There are some of the mussels clumping right there. This is, we think, about 500 years old, that this marsh was there on Sapelo, probably when there were still Native Americans there before the Spanish showed up. And then that mud got buried under beach sand, and it was compressed so that you can jump up and down on it. You're not going to sink into it. But it's also preserved all of these clues about the original ecosystems there. This is in cross-section where now you're seeing some of the fiddler crab burrows, but you're also seeing the roots. And you understand then that Spartina, a really important function of Spartina in the marshes is those roots holding that mud together. So the mussels and the oysters, they're putting out that sand-sized mud, but then it's really up to the Spartina to hold that mud in place. If you didn't have the Spartina, they wouldn't be marshes, they'd be big muddy bays instead. What's also cool is sometimes you can go there and you'll see some of the tidal creeks. So you can see right over there, there's a modern tidal creek there. With a drone, this really shows up. It's so cool. You can see the meandering tidal creek filled in with beach sand now, getting eroded out, but it shows you what was there in that original ecosystem back then. You can even find some of the quahog clams, some of their shells in here. That's where they like to live, or in those tidal channels. Here's the coolest thing. I saw this about maybe 7-8 years ago, and it just shocked me. This is the Relic Marsh. But look, is it zombie Spartina? No, it's modern Spartina. It's actually growing there in this 500-year-old marsh. It doesn't know it's 500-year-old mud, but there it is, it's growing. So this was really exciting the first time I saw this, but then I thought as a geologist, oh, that'd be really confusing. Because if that preserved the geologic record, I would think, oh yes, it was one happy community all living at the same time. No, 500 years separating those two communities of plants. And fiddler crabs, there are also fiddler crabs, modern ones burrowing in where the old ones were. Now this relic marsh that's on St. Catherine's, what you can sometimes see is some of these clams that specialize drilling into what we call in geology firm grounds. So this would be what I just described, where if you have the mud in a marsh, you compact it, squeeze out that water, now it gets more like modeling clay. Once you get that, it's a lot more firm. And there's some animals that just can't burrow into it. But these clams will bore into it. What they do is they kind of move their shells, kind of like corkscrew, and they go in, and there they are, making those kind of traces. So these are false angel wings, and some of their relatives, they will then dig into these firm grounds. These fossilize too. So I've actually seen fossil examples like these in other countries where you actually sometimes have the clam still in there. So a rare instance of where you get the trace with the trace maker, it tells you what the sediment was like then. So again, this is on Jekyll. There's Ruth there in the background for scale. This is on Jekyll, and I was just so impressed to see so much of this crop out. But then you can see why, because there's all of those boulders from the Piedmont province that were put down there to save the beach. Doesn't work. It actually accelerated the erosion. So now it's actually exposed that relic salt marsh there. And you can even see some of the original trunks of some of the pines that were there on the edge of the salt marsh. So that would have been like going up into the high marsh, maritime forest. That used to be in that area that's now a beach. Okay, if you don't mind now, we're going to switch a little bit more toward traces. I hope you're okay with that. Yeah. So you got kind of the geological grand tour. Now we're going to go into some traces, and from what I understand, these are in that book that's right back there. Is that correct? This book is called Tracking the Golden Isles. And it looks like you have a big stack of them there. Wow, that's cool. Okay, anyway. Here are some of the chapter titles in here. Ghost crab tracks here with wind ripples. And I'll just give you kind of a little tour through some of the traces that you might see. So this is how you can be kind of a beach detective. That you could go down to the beach and sometimes you'll see these little bumps in the sand. Saw those on Cumberland Island last time I was there. Those are from Donax clams or coquina clams. Then you'll see also on some of the Georgia Barrier Islands these little bumps. If you just dig them out a little bit, they'll have the little dwarf surf clams, Melania. So they'll do this shallow bearing at low tide, but then if you look for these little holes, the holes are from their siphons. So they have siphons that go up like that, so you'll see paired hole, paired hole, paired hole, and that shows where they are. When they die, they go to coquina heaven, of course, but then their bits and pieces then get concentrated sometimes in the surf there too. So yeah, these are both from Cumberland. Now my favorite, of course, are the ghost crabs. The ghost crabs just have these burrows that are everywhere. They dig them almost all year round. If it gets a little cool, how cold did it get here in late December? Did it get down? 30s. Yeah, 30s, yeah. The ghost crabs are probably not liking that. So they probably burrowed and plugged the top of their burrows. That's how they keep from freezing. So usually about right now, February, a nice day like today, there would have been a lot of ghost crab activity. Where you see the two holes, that's from a Y-shaped burrow. Not an MCA-shaped burrow, but a Y-shaped burrow. Here, this would be more of a J-shaped burrow. So this would be a burrow that would go down like that or go down like that. And they have a little turnaround chamber down at the bottom. These go down about a meter, so more than a yard. I've actually taken a tape measure and impressed my students where I just go, keep going, and it keeps going down the burrow. So really nice environment for them. And there's a ghost crab that actually stood still long enough for me to take a picture of it. They are the third fastest animals on Earth when you look at body length versus distance they cover. The two that beat them are tiger beetles. So they are really fast runners. If you've seen them, that's why they call them ghost crabs. They're just gone. But there's the Y-shaped burrow. See how that's been filled with sand? You also see the heavy mineral deposits in there. So this is in the side of a dune that you can actually see the ghost crab burrows sometimes in beautiful cross-section like that. Now these were such a cool little mystery. Ruth and I, we were walking on Sapelo at Nanny Goat Beach at low tide, and we started finding these. This is where a crab laid down, so you can see, yes, the bottom of the crab, it laid down, and it has tracks leading away from it, but no tracks leading to it. What? Did it parachute? Did it jump? Did somebody carry it there and set it down? How did it get there? And then after a while, I realized, oh, the tide was up, and as the tide came down, they were thirsty, and it was at a high tide where there was a full moon, high tide. They were out of their burrows all night, and they got thirsty. So as this tide started going down, they went down to the surf zone. They flattened down in the sand, and then they draw up water through the little kind of hairs, setae, that are on their legs, this capillary action. So this was something I'd never seen before, and then they just let you take a picture of them. They're thirsty. They're just like, yeah, okay, yeah, I gotta get some water. So this then we documented in a paper, and then later on some paleontologists actually found fossil examples of these in Italy in Pliocene age rocks from about 3 million years ago. So that was a really cool aspect of seeing something I'd never seen before, a little mystery, and then we could apply it to geology. Another thing we've seen too is that, how many of you have ever seen the little baby horseshoe crabs? Like little babies, like on the tip of my finger. They make these beautiful little traces. What you do is you look for that little, the spiky bit in their back, that little spiky tail. Look for that little groove in the middle, and then you'll know it's not from a small snail, that it's actually from a horseshoe crab. Once they get a little bigger, that one was like about that long, then you'll start seeing the distinctive tracks from their feet. But otherwise, the little baby ones, you'll probably see those like after about July or August. You'll be seeing those in the sand flats too. Now this is one friend of mine who's at Georgia Southern, Kelly Vance, took pictures of these on St. Catherine's Island. And this was remarkable because when he found them, he sent me the pictures like, check this out. And I was like, wow. So it was like a horseshoe crab doing this. And what you're seeing is the spikes of the tail where it was on its back and it was using its tail to try to get itself righted over. And it did a complete circle. You can see it did a circle here with the walking, but then trying to do that and actually wore a little depression there. So then when I was looking at the pictures after Kelly sent them to me, I was like, wait, how did it get out of there? And he's like, oh, I picked it up. I was like, oh, okay. That was nice of him. So then you're actually seeing the trackway spiraling back to the sea there. All right, yeah, how many of you have seen these nice little drill holes? Yeah, and you're thinking, oh, those would make great earrings or a necklace of death, right? Because these are from moon snails. So the moon snails are predatory, and what they do is they will engulf their prey. They'll extrude their foot and this engulf them, and then they have this little tool, kind of like a file, that's embedded in their tongue, and it's called a radula, and they start grinding, and eventually they get through. And then once they get through, then they basically put themselves inside and they eat this animal alive. I keep telling Sci-Fi Channel, I will write the script. I'll do it. It'll be fun. Like a 5-foot-tall moon snail, and they find the victims just with a big, yeah, it'd be fun. Anyway, if you use that idea, make sure I'm in on it. So check this out. They also eat each other. Yeah, so these are an example of cannibalism, where whenever you see, that's a live one, that's a very dead one. Whenever you see these then in the fossil record, and I have a paleontologist friend who, she told me she's probably measured more than 1 million of these over her life. She studied the evolution of this as a way of predation. How long did this kind of predation happen over the last close to 100 million years we've seen this. And this is what their burrows look like. So at low tide, if you ever see this kind of soft serve ice cream type of view right there, there's a moon snail right under there. So my former advisor, Bob Fry, used to refer to these as the lions of the tidal flat, because they are the top predators below the sand surface, and they're out looking for food. It's really cool animals and how they hunt too. Now in some of the barrier islands, this also surprised me. There are crayfish burrows, freshwater crayfish burrows. So these on this one on the left, that's from Cumberland. This one is from Jekyll. And I haven't checked recently. They're in a place, I'm not going to tell you where they are on Jekyll. But it does make me wonder, and this is where I want to work with some crayfish specialists, how did they get there? Because crayfish do not like salt water. My hypothesis is that they were left there. So when sea level went up about 10,000 years ago, that used to be part of the mainland, those islands, and the crayfish then, their population stayed there. And they probably evolved a bit off of what they used to be from the mainland species, but I'll bet they're genetically unique. So it's something where on the islands, whenever I've seen these, I've seen them on Cumberland, Sapelo, Jekyll, and there's one other island where I've seen them. It's something that I would like to do a little bit more research on this. Kind of a little mystery that was unexpected. Now I also like looking at the insects, and as a kid, I used to tell people when I was 5 years old, they would say, well, what are you going to be when you grow up? I was like, an entomologist, because I love insects. And it was nice to be able to look at these examples. This is from Tybee, these examples of these sand wasps that were burrowing into the dunes right by the beach. So these are insects that are right there next to the beach. They're burrowing into the dunes, and that's a mother wasp. She is digging that burrow so that she can lay eggs in there. She gets paralyzed prey, puts it in there, and then lays the eggs on it, and then the prey stays alive, fresh food for their grub. Yum. Okay, here's a fossil one. Remember that picture of me in Montana? That's what I was studying. So that's actually a fossil cocoon in the end of a brooding chamber. It's identical to what you would see with modern sand wasps. So this is an example of where even on an island like Tybee, which is pretty well developed, you can still do some really cool natural history when you look for these traces. Okay, now we're going to get to vertebrates. So beaks and bones, a few examples of those. These I love. I love finding alligator tracks, and I especially love finding alligator tracks coming up out of the surf. And I especially like finding alligator tracks coming out of the surf when I'm with a group of Emory students who I knew were swimming in that the night before, and they thought I didn't know. Did I do that to you? Yeah. I was like, whoa, look at this. There were alligators out there last night. How about, you never know what they might find out there. So anyway, we found these on, this was on St. Catharines. Yeah, this was on St. Catharines. One of the storm washover fans where the sand from storms had covered part of this marsh. There was this big alligator, that's 10 centimeters. So the tracks, rear feet are about like that. Yeah, this was a big one. It's probably close to a 3-meter long alligator. What was cool was, notice the raccoon track right there? Came afterwards. Yeah, what was really cool was later in the day, we went by them, the fiddler crabs had moved in. And the fiddler crabs had started erasing the tracks. Look at all of those sand balls that are in there from the fiddler crabs feeding off the sand. So I realized when I've studied fossil tracks, how rare those are, because in this kind of an environment, here's this massive reptilian animal moving through there, and the fiddler crabs just go, start erasing it. So that chapter I wrote about this, I called it Erasing the Tracks of a Monster. And this picture that Ruth took of me here, this is also a very large alligator coming up out of the surf. It's going up toward the dunes. It went over the dunes, and then there was a freshwater pond before there. So basically, these alligators were going out for fresh seafood every day. They were living in their freshwater pond, and they were going out in the ocean and finding what they could out there. Now, these are from ghost crabs. So ghost crabs, again, in about 2 hours later, we came back. You can see some ghost crab tracks there. But about 2 hours later, when we came back to the spot, the ghost crabs had also almost erased these tracks. So it's something to think about, and when you see these beautifully preserved fossil tracks, how special that is whenever you find them. And this was thrilling. We actually got to see one. We'd seen their tracks on beaches for years. And finally, it was 2019, I think, yeah, when we were there on Sapelo, finally saw this one out of the surf. I was so happy to actually see it. Okay, now birds are, how many of you like birds? Yeah, we love birds. One of the things I love about the Georgia Barrier Islands is that all of the examples of bird tracks and bird behaviors that are represented by those tracks. So it's one of my favorite topics whenever I come to the Georgia coast and look at the bird tracks, whether they're shorebirds, wading birds, whatever, what are they doing? So these for years I'd seen, these are landing tracks. So sometimes I'll see those from the gulls, sometimes I see them from great blue herons, from great egrets, sometimes some of the smaller birds, pelicans too, that these landing tracks where they just come to a skid. So what happens is that they're flapping, they're coming in, and then the rear feet, one of them contacts the ground first, then the other one does. So it's like boom, boom, like that. So because it's moving so fast, you're going to see that rear toe is going to be having a long scrape on it. This one also has that scrape. But this is where it's coming in for landing. You're going to see that long scrape. Look at this thing over on the right. That's a fossil bird track from Australia. It's about 105 million years old. So it's been collected at a site where they found 2 other tracks with it. They had it in the museum in Melbourne. And when I went down to the basement of the museum to look at them, I'd looked at the photographs. I said, yeah, I think those are thin-toed dinosaur tracks. When I went down to the museum, I realized, no, that's a bird landing track. And what an eerie feeling that was, but it was because of this, that the Georgia coast birds had taught me what to look for. So we published on that my Australian colleagues and I published on that in 2014. They were the oldest bird tracks in Australia at that time. So then what you do is you have kind of this mental picture for what you would see in the fossil record. And the Georgia coast is world famous for those kind of examples. So this was another little mystery. If I saw this in the middle of the island on a sandy road, I go, yeah, it's an eastern mole. That's a mole tunnel. If I saw it on a beach, I go, what the heck? Notice I said heck. Yeah. I was like, what is it? What made this? And I was so embarrassed later on. I went and looked in the literature. It's like, it looks like a mole burrow, but what's a mole burrow doing where they would actually go down to the surf zone? It's like, what are they doing? But then I realized after reading some of the literature, including my advisor who written some of it, about moles actually burrowing down to the beach. I was like, whoa. So really good humbling moment, but also thinking about the changes in behavior of these animals and how moles can be in the interior of a maritime forest, or they can be going down for fresh seafood down at the beach too, making really long burrows there. And these are among my favorite tracks to find, otters. They're utterly delightful. When you see that they are doing these patterns of like 1, 2, 1, that's kind of a lope. And then sometimes they have distance that they get. Now they're in a gallop, and now they're doing like a C-shaped gallop, Z-shaped gallop. Ruth and I, we followed this otter's tracks for probably well over a half mile, and it was having the time of its life. It was just having fun because it was going into the surf, out of the surf, dancing along. This is where you can actually see these stories of an animal's life written on the sand for you to appreciate. Did we see the otter? No, we didn't have to. It was cool. So now we're going to talk a little bit about humans and their interactions with the islands. So some of the geology of the islands, of course, has been modified by humans, but also what humans brought to the islands have changed them as well. So right here, for instance, that's on the north end of Sapelo Island. That's an armadillo burrow. Armadillos were not native to the islands until, well, whenever they came in. Like the 80s, I think, is when they started showing up around the Georgia coast. But they're an example of these animals that when people help them or actually intentionally take them to the islands, they can cause some major changes. So here, for instance, this is on Sapelo Island. How many of you know Sapelo has wild cattle? Okay, good. Yeah, most of you, I figured most of you would know about these. But the wild cattle, they're like straight out of the Pleistocene. I have seen them maybe twice, 3 times, in dozens of times to Sapelo. They are cryptic creatures of the night. Cows? Yes. They're really shy, but you do see their trails, and this really surprised me. This was from a rogue bull that actually went down to the beach. That's the only time I've ever seen their tracks on the beaches there. So knowing about these feral cattle, I think they date from the 1920s from what I remember, when R.J. Reynolds had them there. My colleagues at Emory, they actually used a telephoto to get a picture of that. And they ran away as soon as it snorted and started pawing the ground, which is a good strategy. But occasionally you will see traces of them, and they're modifying the environments of the north end of the island, but we don't really know what major impact they have. Now in Cumberland, on the other hand, we do know that the horses are actually changing the geology of the island. And it's kind of cool to think about this. They're not native to the islands. We've had the horses on Cumberland for probably under 100 years or so, but they have made all of these trails, and they have gone over the dunes, even though it's a national seashore. Like if I went there with a friend and we have a horse outfit, and we went on the dunes and we started eating the grass, we'd probably get arrested. But the horses, they can do anything. It's okay. So what's neat is when you think about these horses in these environments, I'm thinking neat, not ecologically, but neat scientifically, is you start thinking about their effects and how they are changing the environments. So I had an undergraduate honors thesis student in 2018-19. What she did was she mapped the horse trails. So she took aerial photos, satellite photos, and she looked at how did the trails change over time and how did they change in their length over time. She mapped them, and it showed, you can see this on Google Earth. You zoom in on the southeastern end of Cumberland, and you will see it looks like this spider web network of trails. Most of those are from horses. Some of them are from the feral hogs, but most of them are from horses. So what she found too, because there's a jetty there, is that see the sand doing this? That actually also she saw in the aerial photos that the sand was actually migrating west because the trails and the grazing and all of the effects the horses have had on the dunes and the back dune areas there has actually caused the sand to move farther west and change those environments. So a really good example of thinking about, you can look from little drill holes in snail shells all the way up to satellite photos to understand how organisms are changing their environments. And of course the feral hogs on some of the islands are having a major impact on those ecosystems. Those of you who have done sea turtle research or sea turtle trying to protect them during their nesting season, we know that on some of the islands they're a major problem for that because they dig into the nest, they eat all the eggs, and they basically act like pigs. So with this, we have to understand what are they doing, what are their behaviors, how can we protect some of the endangered species there. So that's on St. Catherine's Island on the left in the back dune meadow. That's all rooting that's been done by hogs. And this is on Cumberland Island, actually on the west side of Cumberland Island. Yeah, Carol Ruckdeschel took us there, and you could see this damage going all the way down the beach. So they actually impact almost every environment on the barrier islands, from the maritime forest down to the beach. Now we're getting into some of the human traces, and this is kind of neat to think about how St. Simon's Island used to have some shell rings, and then Sapelo Island still has a big complete shell ring there, more or less complete. How many of you have actually visited it? Kind of curious. Yeah, not many people get up, it's at the northmost end of Sapelo. Not many people get up there to see it, but it's been well studied, it's been mapped. It's also about 3 meters tall. So when I've taken students there, we walk into it, there's a cross section through it, and you can see it's mostly oysters. Some mussels, some crab bits, but mostly oysters from Native Americans, dated to about 4,500 years ago. So it shows when Native people were starting to live on those islands. Then, when the colonial period started, plantations and slavery, they actually, some of the enslaved people at this plantation, the north end, they actually dug up the shells from that shell ring, and there's still a pit preserved there, and then used that for the tabby. So the tabby that you see oftentimes from some of the times of the plantations were actually recycled Native American shell rings where they got the raw material. Now, if you ever go to Savannah, and this was interesting for me because going through here as a geologist, how many of you have seen some of these stone streets in Savannah? These are ballast stones. So these stones are actually from Europe. So I have a nice little chapter in the book about that where I talk about going, as a geologist, going through, these are probably some fossil burrows. And that's a crinoid piece right there. So that's probably from the Carboniferous period. This might be from the Cambrian period. All of these rocks are from Europe. They don't belong there. How did they get there? Well, they were ballast stones on some of the European ships that were coming there, particularly the British ships, where the enslaved people were growing all of the agricultural materials going back on the ships, but the ships were coming with the ballast rock, and sometimes they dumped the ballast along some of the channels. So whenever you see these little islands along the edges of the channel, those are actually human-made islands because the ballast was dumped there. Sometimes there was soil in it too. Sometimes there are invasive species of plants that grew in there as well. These are examples of how humans have modified the landscapes in those ways using geologic materials. Now, of course, now with climate change and now with some of these hurricanes that we're getting, this was on Ossabaw Island from Matthew, and some of you probably experienced it here on the mainland, that it really uprooted a good amount of the forest in Ossabaw, wiped out this road here. One of my colleagues, Michael Page at Emory, he actually went in with some other people the next year and they helped put a little bridge over there to repair that. But with this then, we're thinking about how hurricanes are also going to change the islands. And especially as sea level continues to go up. This is a storm washover fan on kind of the northeastern corner of Jekyll, where you see the forest in the back, that little forest, it's now not forest. This is kind of the so-called tree boneyard that's on Jekyll. This is where the sand has been washed out by storms and now actually going into the marsh. So I've watched this happen over just a period of 6 or 7 years. And you can actually calculate the rate of how fast the sand is going. So the road's right here, and I'm estimating on current rates of change that the sand might actually reach that road in another 10 years or so. So these are things to think about and to see geologic time in that context of how these environments are changing through time. And a geologist friend of mine, Andy Rinsberg, he and I, we did a study on St. Catherine's Island where that brown layer you see right there, we think that's an ancient storm washover fan. And we found fiddler crab burrows in it, we found some insect burrows, a few things that also told us, oh yeah, this was like a storm washover fan, like what you just saw on Jekyll, but this was during the Pleistocene. This was maybe about 25, 30,000 years ago. Look at where it is, how high it is above high tide. That's how high sea level was, about 1.5 meters higher than now. So these, the ancient records that we have here, can give us ideas of what's going to happen in the future. This is from the River Basin Center, University of Georgia, a map showing with 1 meter rise of sea level, what's going to happen to Jekyll. I think the putt-putt golf will still be okay, but a lot of other parts of Jekyll will be underwater. They're going to be more back barrier type of aquatic environments.
We have 1 minute until they fall.
Yeah, so I just want to show you this. These really cool, wow, cool, groovy artwork is actually burrows. You're looking at a cross section. So there's a sea turtle nest. This is showing, this is in the dunes. As sea level goes up, sea level rises, you're going to get more of the marine animals coming in stacked on top of the sediments and the traces made by the terrestrial animals. So this is not just art, it's a hypothesis. And that's something where I want people to think about how these environments that are laterally adjacent to one another are going to go over one another as sea level goes up or down, and the traces record all of that. So just to summarize and review, there's not going to be an exam, don't worry. Okay, geology of the Georgia coast is really related to the Appalachian Mountains and then some of the changes that have happened in geology since then, particularly coastal plain. Geology and the ecology of the Georgia coast, when somebody says, my Barrier Islands class, is it geology, is it biology? I say, yes, it's really both. And ichnology, the study of traces, is really a great tool for being able to see how geology and biology can be combined and how those sciences are not necessarily separate. We can use them for the geologic past, but we can also use them to kind of predict what's going to happen in the future. And I think, yeah, oh, do you have books back there, by the way? Yeah, that's cool. Okay, writing books, okay. Yeah, they have this book, which, as I said, came out in May 2020, so it's delightful to have it here for you. I have a new book coming out too. Yeah, woohoo! Coming out in May, and it's called Life Sculpted, Tales of the Animals, Plants, and Fungi that drill, break, and scrape to shape the earth. So it's a history of bioerosion, of how life has, when life got hard, life made it less hard, put it that way. So that's coming out, University of Chicago Press, coming out in May. So be looking for that. And we also, at Emory, we have the Georgia Coast Atlas. It's still a work in progress, but we have lots of videos, digital maps, and information about the Barrier Islands that we've been uploading over the past 5 or 6 years. So you can check that out, georgiacoastatlas.org. And of course, we always have to end a talk like this, right? And I want to thank 100 Miles, everyone who has taught me everything on the Georgia coast for so long. I always thank the trace makers, and of course Ruth for being my companion, my supporter, my field muse as we're out there enjoying these environments. That's all for now.